So for the second part of the video homework, let's talk about problem 2. So problem 2, we have the condition here that x is uniform in from A to B in A and B, and y equals x to 2. So the question A is about find and draw the probability mass function and the probability density function of x. So for the probability mass function, since x is uniform in A and B, so probability mass function is very easy. It should be B1 over B minus A, and A is smaller than x, B is larger than x. And the probability density function is also easy. When x is smaller than A, it is 0, and when x is in A and B, it should be x minus A over B minus A. And when x is larger than B, it's 1. So next step, let's draw these two functions. First, let's draw the probability mass function. Also is an easy one. From A to B, the value from A to B, the probability value is always 1 over B minus A, and this is x, right? And the probability density function is also easy according to this 3 density function here. We have when x is smaller than A, it's 0. And when x is from A to B, this point should be A, and this point is B. It's x minus A over B minus A, so it's like this way, right? And when x is B at this point, from this probability density function, we can have when x is equals B, so it's B minus A over B minus A, so it's 1, right? So, and when x is larger than B, it's always 1. Okay, so this is all about question A. Let's jump to question B. Question B will have more condition, as A is -1, B is 3. And we have to find and draw the mass function of y and the density function of y. So since A is -1 and B is 3, we can have the mass function and density function of x as below, which is 1 over 4 A from 2B and 0 else, right? And the density function is 0, and x plus 1 over 4 A to B, x smaller than A, x larger than B, 1. And from what do we then do? Okay, let's do it step by step. So next step, we want to transfer the density function of x to density function of y. Since we have known that y equals x to 2, so we can write the density function of y in this way. Y smaller than y. This is the definition of density function, right? So we take this equation into this density function of y, make it as this way, fx x to 2 smaller than y, right? So this becomes the density function of x, which is right. Okay. So an easy transformation from right here. This is y minus fx, right? Okay, so let's take the density function of x into this part. That's what we need. So it's when y is smaller than y, than 1, right? And it's when y is from 1 to 9, which makes x from 1 to 3, right? This is the easy part, right? We don't have to do more explanation. And the density function is 1 when y is larger than 9. So let's make it simple, this part. It should be y smaller than 1, 1 to 9, 1 larger than 9. Okay, we have got the density function. The next step is to get the mass function, which is the derivative of density function, right? So we have this derivative over y, density function. Oh, sorry. And it's an easy job. Just some derivative calculation. Okay, we have got all the function we need. Then let's draw the picture. For the first, let's draw the mass function, which is this. Let's make some point 1, 9, and then it should be this way. Right, when y is equals to 1, it is 1/8. So it's this part. But for this part, when y equals to 1, we have 1/4. So it should be right here. This is 1/4. Then when y equals to 9, it is 1/24, right? So it's like this. Okay, yeah, that's all. And when y is larger than 9, it's 0. So it's this part. Okay, this is the drawing of mass function. Then let's draw the density function. Which is also, this is 0.1, this is 9. And with the density function, we know that when y is equals to 1, it is, when y equals to 1, it is 2/4, so it's 1/2 right here. And when y equals 9, it is 1. Right, so it's like this.